Yo, 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 good morning. So, we're still working on the activity texture, and I had to leave in at a cliffhanger, or with a cliffhanger yesterday. We're currently implementing it, the activity texture, using a command buffer and sending commands down to the GPU or to draw to a texture or a render texture, as opposed to using compute buffers and calculating a lot of stuff on the CPU as we did previously. So yes, we had a problem with, let's see if we play this one, what we have currently. If I remember correctly, I think the problem was that we use one and the same material for each draw command, which means that all of the objects use the same material and the velocity gets screwed up. And what do we have? Okay. So we have entity now has a activity properties. We're probably gonna rename this eventually. It also has a list of renderers. If we try and get renderers and this list is null or has a length of 0, then we just get all the renderers in the full hierarchy. So for dynamic entity in update, we do activity properties, set vector velocity, we set the rigid body dot velocity, and then we call environment controller terrain occupy this. We calculate a terrain subset, or we create a terrain subset, and then we get all terrain patch indices, and for each terrain patch indice we render this entity to the activity texture for that patch. Just like that. And in the end, in terrain base end here, we have late update command buffer, execute command buffer. What I'm wondering though is we set this one, but we never use this one with the we never use this one, or we never set this one for the renderer, I think. I wonder if we need to do it every frame or if we can do it once. Yo, good morning, Harukanon. Like, I wonder if Okay, let's try and do it like this. Entity, activity property, let's do field. Get protected set. And in terrain patch, when we do this, we can here we can do entity renderer set property block entity dot activity properties. I'm not entirely sure if this will work, but this is one way we could do it. Would love to be able to just set this one in entity awake as well, or entity start. We can look into this soon. Okay, that's nice. Fucking that looks really good. Okay, let's enable this one. Bam. Okay, doing it like this works. Pretty good performance as well. Let's add. This looks fucking great. Haven't even started to optimize it more, or to clean it up. Okay, this looks beautiful. Oh, love it. Absolutely love it. I want to see what happens if we do this. If we go a little bit crazy. Resolution. Let's multiply this with 4. 2048. Yeah, let's do it. Hopefully we won't get a crash. 2048 divided by 2 divided by 2. 512. That's not too bad. So each terrain patch has an activity texture, or actually all its data is stored in. The problem isn't going to be. The problem is actually going to be vertices in this case. That's why we're getting such a bad FPS, but that's okay. I would love to be able to support varying, so some data texture should be. Fuck, Fucking hell, this is beautiful. Derek, LODs that sort of mimics Cascade shadow maps would be dope for this. I haven't done that much shadow map development, so I don't know, but definitely gonna look into it. So are we talking about for the activity textures or LODs that mimics Cascade shadow maps? So are we talking about so this one how to kind of painting the world one step at a time. Yes, indeed. Pretty damn. It feels real good as well. Yeah, what's up, Cooler SK? Let's add some other objects. So pretty much with this solution, it doesn't really matter what resolution we have on the texture. Yeah, of course it should affect the performance a little bit, but we should be not nearly as much as it did with the previous solution, that's for sure. Derek, basically it works exactly like normal LODs, but with textures. Close to you is high res, and there are step downs as it gets further. And yeah, I'm talking about activity texture. Yes, exactly. Yeah, definitely. I could see that. I just wonder... Yeah, I think we're gonna do some very interesting stuff with this. I mean, I would say that this is already quite interesting, but we're gonna make it even more so in the future. That I do not doubt. But this is pretty damn cool. I wonder how we could... I think we could do some very... like... I wonder if we could do... So right now, we pretty much, when we render, let's see, we take a look at the character. When we render this character for this texture, we pretty much do isometric, and then we do from the top. For some reason I can't really see the character here, but... we pretty much render it like this, right? But that means that things that are close to the camera, so high up, a great distance from the ground, will actually paint the ground, like we see here. So we can see here that the hands actually paint the ground here, and that's probably something we want to do, but I wonder if we want to paint it, like I wonder if we can pack data and draw, if we can render stuff in such a way that we give more information to the data. Right now the only information we send in is the velocity of whatever occupies a pixel, isometric top down. I wonder if we could we're always going to draw the velocity in some capacity, but we want to draw minimum height, maximum height, or if we want to pack multiple heights. I don't know. Having rain not fall through things would probably work similarly. Maybe. What's up, hard dev? So let's take a look at activity output. So this is pretty much everything we do here. We project it downwards using the projection matrix. Then we output clip space and UV. And all we do here is we output velocity x, y, z. Yo, good morning, Geralt. So now we're back at the discussion regarding this one. What the fuck do we want to store in this data? Height min, height max. I wonder. Okay, we rely on Unity's time instead. Time since level load. T divided by 2. Yeah, I guess we could. Fuck me. I mean, with storing this data, we could probably achieve good enough for most things, but I can't help to think that there must exist a better combination we can store. Like, probably don't want to go probably don't want to use more memory than this. So we have a timestamp, which is one. What the fuck is it? Yeah, it's a float, so it's 32 bits. And then we have 4 bytes here. So 64 bits per pixel. Yeah. I don't even know if we do this in render texture style as we do. Render texture Unity. And then I want to double check. Yeah, we don't want to use. I don't want to introduce a depth. No, I don't. I don't even know what the default is. Width, height, depth, format. Yeah, read, write, default. So where do we have MIP count? I mean, we could probably go. We can save it as ARGB float, would give us 32 floating points per channel, or 32-bit floats per channel. But that's a lot of data. I don't know. Maybe it's not too bad. But then again, then we get the question. So if we go crazy with the data, so we allow for 32 times 4 then per channel, what do we store for the best result here? Or do we, let's see here. And also, let's see here, Unity HLSL blend operation. Separate RGB and alpha blending is not compatible with anything that specifies a render target requires. But this one, because I mean, if we want to store minimum height and maximum height, when we want to render it, we probably want to do override whatever we have at minimum height value if this one is less than it. So we want to use min when we do a blending operation, but we want to do different types of blends per color channels, but I don't know. Okay. Okay, advanced OpenGL blending operation. Logical operations should be good. Use a smaller source and destination. Like, this is beautiful, but I would like to have per color channel eventually, if that's possible. Logical operations requires dang. Yeah, maybe we don't want to rely on that. I mean, we could have one subshader or one pass that only outputs to one subshader that only outputs to R, one subshader that only outputs to G, and so on and so on. But if we always want to output the smallest value, we're probably going to have to introduce depth so we can compare them. Okay, if we just think about the easy case for now, so at most we only have one object that occupies a pixel at a given point, so we never have more than one object. And we want to store minimum depth, maximum depth. But that doesn't, like, even if we only have one object, we might have multiple vertices of that object that occupies. And if we don't do any blend 1 0, if we don't do any depth checks, so let me just draw something here so I can try and visualize. This again was a very easy problem to solve on the CPU. I have a little bit more tools to work with on the CPU and information. So if we want to solve the same issue on the GPU, so basically we have the ground, we have a little bit of a person. And then we have the different data points. And then we have our camera rendering from here, doing orthographic as well. So if we render this, if we wanna, so the most basic data we wanted to store was minimum height, maximum height, direction of movement, and strength of movement. Direction of movement and strength of movement is easy because we just set if we only have one object. Nah, I don't want to do that. For a brief second there I thought maybe we could do something similar to what we're doing here, that we're actually setting it ourselves, but that won't really work. But so for instance, for this one, for this data here, we would have like to have the minimum height should be here, and the max, yeah, the minimum height should be here, the maximum height should be here. So this is pretty much what we have for this data point. The velocity direction is the same for the full object, so that won't differ between any of these. The velocity strength is also similar right now. I'm okay with that. We save timestamp as well. We save the same timestamp for all three. So the only difference between them is pretty much this one and this one, or the minimum height and the maximum height. So for this it would be here and here, and for this one it would be here and here. So how do we get these values and how do we render these values? For the maximum value we could probably do, if we allow for depth checking, we could render with cull back, and whichever has the shortest depth is what we render, so it's this one. For this one later on we could probably do cull front, and whichever is furthest away. So depth, can we do in ShellSL Unity depth check? But anyway, we could do some sed testing. But so if for max, if we did for max, for this one, the upper one, we do cull back, and we do sed test L equal, I think. then we would render this. So we can render the depth value of this, because we get this point if we do it like this. And for the bottom we could probably do col front and sed test greater equal, maybe something like that. But that means that we would have to split it up in multiple different passes. And we also have the problem of this one wanting to write depth and this one wanting to write depth. So they're gonna be in conflict of who should write and when it should be done. The comparison would be wrong. So we can't really do it like this. We could do it like this if we had multiple different textures, I suppose. If I remember correctly, we can't write to a render texture at the same time as we read from a render texture. So we can't really, when we want to output this one, we can't really do, I don't think we can read it in the, I don't think we can read the value and compare it in the shader if we don't use, I guess you could probably do something similar if you rely on these, because that's basically what we do with min here. I've done, let's see here. Just have to double check. Right to render read write and while reading from it Unity. Yeah, that would be beautiful. I don't really know if we want to clear it yet. So set render target, set global texture grab text render target. Yeah, I don't want to do... But... I mean... Probably wouldn't be too bad. We could just have one... I mean, we could do this if we wanted to. So we have one render target copy. We have one in terrain base, and then we just switch it out per terrain patch as we go. So we can have the previous values and the current values. But, nah, it still won't solve the problem we have, or the problem we're trying to solve, by getting the max height and the min height. Because if we have multiple vertices, so vertex, vertex, vertex. But one sec, never mind. it's pretty much where do we have it? Would love to be able to get yes, for each pixel we would have the minimum height for that pixel and the maximum height, because then we could basically get some sort of shadowing. Like we could roughly rebuild the shape of whatever is occupying the ground. Yo, what's up, Cynic? And thank you for the sub, appreciate it. 11 months. Yeah, it goes by quick. I'm pretty sure we need the min height and max height in this data texture, but I'm not sure how we could get it there with the current approach, which sucks. Assuming it's this for grass displacement, yeah, among other things. So it's going to be for water as well. It's going to be for snow, rain puddles, whatnot. Eventually. But I'm having a little bit of a problem of... So I think we have converged towards the fact that we're going to save these for... We want to save this data for per pixel. So timestamp when something was visiting it, height bounds of whatever is visiting it, direction and direction strength. This one, and this one. Extremely easy to solve. We pretty much already have it. Height, not so much. When we create these textures, we pretty much render the terrain from... Or not really, we take every entity that has moved on a terrain and we project it according to our orthographic camera from above, and then we render the specific stuff we want down to the texture. But I don't know how we would go about rendering max height and min height, so we get like a height bounce per pixel. Yeah, so that's the current problem. Like so we're watching the character from, or we're projecting it from above pretty much. So for data values here, we want to have a, like, these should be closer to the camera. These should be further away, right? We can get one of them pretty easily by just doing, by introducing a depth texture and doing depth comparisons. Derek, basically a depth texture. Yeah, that's basically what we want, but we want for each pixel we want 2 depth values, right? But yeah, thinking about it like a depth texture, that is that's a perfect way of thinking about it. And we can get one of the values easily. We could actually get one of the values by just introducing depth in the render texture, I guess. But fuck it, maybe we can do some cool stuff here. Unity HLSL render to depth of render texture. Derek, min height would just be vertex height in view space, or you could convert the depth value to world space, however you want to do it. Yeah, like the values themselves are pretty straightforward, I think. It would be position.z in view space, I think. But let's say, for instance, that we wanna let's say, for instance, that we want to draw this max height here. If we don't have any depth texture or do any depth comparisons, we might have a vertex here, we might have a vertex here, we might have vertex here, 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 and here. What I'm trying to get at is the fragment shader might run many times for this data point per the object. So which of the different fragment shader runs should we store the value for? And that's why we need to do some comparisons. Let me try and rephrase that in a way that makes more sense. The object that is occupying a data point when we render the data to the data texture, we do it using the normal pipeline of vertex shader, fragment shader. It's just that this object might have multiple triangles that occupies the same pixel. So that means, so if we have a pixel here, it means that this fragment shader will be run. We don't do any culling based on depth currently, so this fragment shader will be run 3 times for one object here. So the question is, which of these do we store? And now it feels like I need to have some knowledge gaps here, exactly how the pipeline works in Unity and such. For instance, do we always sort based on depth, i.e. will the first fragment program that runs be the one that is closest to the camera, and the one that runs last be the one furthest away from the camera? How does this work when we don't have a depth texture, and on and on and on. So a lot of questions, not a lot of answers currently. And that's what I mean by if we could introduce a depth texture and compare it, so we cull front, cull back, then we would, for max height, we would only draw the polygon closest to the camera, and for min height we will only draw the polygon furthest away from the camera. Whatever the answer is, hopefully it's not hardware dependent. Yes. That's something we want to avoid as well. Fucking sucks implementing something after a lot of problems, workarounds and such, and you finally have it working, but it's extremely hardware specific. But that's why I was looking at these previously, because I wonder if there exists some cool stuff we can do here. Use the smaller of source and destination. Yeah, destination is our render texture. So for instance, if we would be doing blend op, but then we have to min max, we have a lot of logical operations and stuff like that. So if we would be using any of these, our hard, let's see, 1 logical operations. Yeah, so if we use min or max, then we need DirectX 11.1 or Vulkan. So that limits everything for us. But let's assume we could use it. So then we could do blend up max. Let's see here. Yeah, so we do blend up max, which means that if we output maximum height, we would check against our output, and we would only change the render texture value if whatever we output is more than we have stored currently. So that works for if we could do blend up max for so height max, then we use this one, and for height min we use min. But this means that we would like to do, if we want to pack this into a float 4, so that means that we would be doing blend up min for the red channel, blend up max for the green channel, and whatever for blue and alpha channel. And I'm not entirely, I don't know if we can do different blend operations per channel. If we take a look at this one, separate RGB and alpha blending is not compatible with advanced OpenGL blending operation. Is not, yeah. Which means that we can probably not use DirectX, we will essentially have to do 2 passes for it. Yeah, sure, it does. It looks like it. Or have, yeah, at the minimum, or have, I don't know, multiple render textures or something. Yeah. But then again, like this is, if we can find, if there exists some other data we can render to this data texture that is better and makes it easier and roughly leaves us with the same possibilities, then we might just switch to that one instead. So instead of having height max min, if there exists something else we could have, I would be okay with that as well. I'm also not entirely sure what they mean with separate RGB and alpha blending is not compatible with advanced OpenGL blending operations. Okay, so we go here 1, 2, so this one and this one. Enables blending the default render target, sets separate blend factors for RGB and alpha values. That's fucking beautiful. So source factor RGB. Okay, set separate factors for RGB and alpha value. So it's not separate for R, separate for G, separate for B. It's just RGB and alpha. Same here. But if we do blend operation color mask, this one, so what we can do is you can do color mask R, which means that we only write to the red channel. So we could do, worst case, we could do multiple passes, one that does multiple sub shaders. Do we want to go multiple sub shaders? Multiple. And maybe multiple passes. One that writes to red, one that writes to green, and one that writes to B and A. But because then if we could do color mask together with use it in a pass for that pass, or use it all passes in, yes. So we could probably mix this one together with this one. So yeah, let's try this. So we would do RGB R, blend op min, and then we would have one, but then again, like this one, let's see here, we can probably cell shade, lit shader, how do we do it here? Pass, sub shader, yeah, let's do HLSL include. Something like this. So vertex shader input and vertex shader output will be the same for all of them. The vertex shader will be the same for all of them. The fragment shader will be different though. So we have one pass that outputs to the red channel and we do minimum. I don't know about this. I don't know. Then we have one pass that outputs to the green channel and we do max. I don't know. And then we would have, I wonder if you can do BA. Yeah, beautiful. Beautiful. Render target index. Okay, yeah. That is if we set multiple render targets, I assume. Command buffer unity. Set render. Don't we have? Yeah, so if we set multiple render targets, then we can choose which one of those we want to draw to by doing 1 or 2 or 3 here. That's pretty cool. Maybe we can use that to our advantage eventually. I will get to that one eventually. Let's see if we can make R and G work here. So but yeah, we need to fix our view space. We need to fix the view space matrix. I think that's wrong currently. So let's do world space for now. Like this. So here, world space, we want to go with Y here. But I want to do some inverse lerp or something. And let's go 2 meters maybe. So float V is equal to inverse lerp. Saturate inverse lerp. Min max value. Two. So we do it like this. We only write to red channel here. We want to do the same here. But max, so if the output is, so if this one is bigger than what we already have, then we set this one, otherwise we don't. If this one is smaller than what we already have, then we set it, otherwise we don't. For BA, I don't really care too much about these for now, so we might as well keep it like this. But given this one, we will only output the Z and alpha channel, or blue and alpha channel. Do we have any errors if we do this? So this is activity output. Now I want to see terrain activity debug shader. What do we do here? Fragment shader, calculate UV, we get the activity data, and then we use the direction. Get terrain activity data from texture, terrain activity data, UV, what the fuck, okay. Data. Whoa. Yeah, we probably want to fix the UV in here eventually. That would be way nicer if we did it, but whatever. So previously we had data like this, but we don't now. So let's see here. Height, boundaries, what we're going to do now is, so this is previously, now we do terrain activity data dot height boundary is equal to float2 data dot r data dot g, and that's about it. And then we can do tangent to world. We're gonna wait with this one. And wait with this one. Direction color. Let's start with activity data dot I mean, we could pack them into the same, but I want to try them each on their own first. So float for height min color, activity data dot height boundary dot x 0 0 1. Okay, so what have I missed? Can't we do it like this? Do we need... Now, if we don't specify blend, we should be getting default, right? So what am I missing? What am I missing? One sec. Or HLSL. HLSL include and HLSL. Nah, should be okay. What the fuck? Sure, yeah, it's not this one. Like, I'm not missing any parentheses. Don't think so. HLSL program. Should be able to do it like this. Let's do. Does that actually remove it? Okay. So what's wrong with this? RGB. Oh, do we need another pragma? Let's see. Fuck, I'm tired. We need to do. We need to change. This one is supposed to be color mask. There we go. Okay, let's try it. a little bit worried about this, the time it takes here. 45 seconds, that's not good. And we don't have anything here. Okay. Not too sure. I don't know if that helps, but let's try it. An environment, let's divide this one by 4. Still nothing here. Min, because we probably have 0 here by default. This one should be visible though, so I want to try height min color. Let's do height boundary dot y. Okay. And then we can do I think this is pretty good. Let's do let's enable these. Let's take this one and we do 0.1, 0.1, 0.1. Maybe it's a little bit too small to even be rendered, but we can do it like this. Looks to be all right. So one sec, this is max height. So if we do, if we take this one up here and do 2, then we have it like this. And this looks good. So this is max height, but we need to be able to override it as well. But we only want to override like that if timestamp is far away as well. Okay, I want to see how this looks if we do environment. Times 4. We want to have minimum value as well, minimum height. And we need to figure out, so now we only override it if it's less than or if it's max, more than. But we also need to keep track of timestamp, or we need to alter these values based on timestamp as well. So we can see here that the arms, yeah, they don't give as big a red value, and if we jump we get more red. Beautiful. We could reset between iterations as well. Nah, don't think we want to do that. I love that you can see the hands here in front. Dark fields of blood, yeah. Okay. Then we have the question of the minimum height. Yeah, this is max height, and then we want minimum height as well. The only problem being that for the minimum height we need to add an additional value, otherwise this will never be true. But still, Or we could do max here as well, but we just revert this in some way. Fuck, I'm still wondering if... Now when I think about it, I think we should, or it would be way easier, but also a lot more objects, I suppose. But yeah, maybe this wouldn't be too bad. Yeah, definitely. Instead of doing entity renderer and so on, we do what the fuck? Maybe this is what I want to do. Command buffer dot draw mesh. Fuck. I'm wondering if Collider Unity. It would be nice if we drew the collider meshes instead, and then we send down the collider parameters. So I guess width, height, and so on. But still, it just feels like we would get a pretty good foveated. Okay. Yeah, I'm just not sure about this current approach. With min height like this and max height like this one doesn't work unless we set the initial value, and the question is, when do we want to reset it? But I mean, we can reset it each. We can probably reset it each iteration. But it still feels like we... I don't know. Yo, what's up, Harry? What's going on? I'm just... trying to figure out what data we want to store and how we want to store it to be able to use it for the best possible outcome. Like, it's this question all over again. Is this everything we need to properly do some cool stuff? Do I need other data? How do we store this? When do we replace data? For how long do we store data? Just boring questions. One sec, just gonna grab coffee real quick. Like, I mean, if we want to go extremely crazy, we could probably make the activity into a 3D texture and just, but no, I don't want to do that. Because it's quite, if we take a look at, if we want to use it for snow displacement, where do we have it? Because if we want to use it for snow displacement, the only thing we need basically is we need a minimum height for a data point ever. So what is the thing, or how close to the ground have we ever been at this point? That's all we need for snow displacement, I would say, or similar displacement. Water and foliage, though, is a little bit different. It's more dynamic. want to check, what did we have here? RGB float. Per channel. I mean, fuck, how do I want to do this? Having it's like, I'm wondering related. So at any given, or when something is occupying a data point, we store minimum height at that data point, maximum height at that data point, velocity at that data point, velocity direction and velocity strength at that data point, and then we also store the timestamp. Okay, that's fine. So every time we update a data point, we take a look at what's the minimum height, maximum height, velocity strength at that point, and we store that information. But how do we handle... So then if we have another object, so later on we have another object that runs through and occupies points where we already have some data. Of course, the timestamp should change, the velocity should change, and the velocity strength should change. But so should min height and max height as well, right? But if we change those two, then it's a question of what if at one point we have this character running through a snowy landscape. Later on we have some other object flying past it. Won't we get a problem at... If some object moving past it a distance from the ground and we override min height, then our snow shader will get fucked up because the min height will be a value that doesn't really displace the snow, and we get snow back here. So we need to store more data to be able to do all of these different scenarios. Eric was up, slowly developing a painting game. Yeah, that's pretty much what it has become. Oh, fuck, I want to draw this data. I want to draw this data to a texture, and then I want to recreate how it looks later on. That would be very cool. But fuck it, maybe I'm just overthinking stuff. Maybe we should just implement this and we always draw... But one sec. What if okay, so if we go with a solution that we always draw min height, max height, timestamp, and velocity. So we always draw these four. We always overwrite them. But how would that look with this one? Yeah, I'm not sure we could make that work with blend operation min and blend operation max, unless we reset this one between frames. I guess that would be blend op min. Could we do... probably not. Yeah, so if we choose to always write those four variables or those four data values, then we can't really rely on blend operation min and blend operation max, because we will never overwrite those. Or rather, we would have to take timestamp into account as well. So it would be, if it has the same timestamp, so when we would draw this, for instance, when we would draw minimum height, we would need to check what is the current timestamp for this data point. If the timestamp is the same as this one is trying to draw, then compare min height. If the previous timestamp is smaller than current timestamp, then just overwrite no matter what. So then we could probably do blend operation min. We would probably want to do... oh, fuck me. I don't even know how we would do this. if we would I would say that most of the problem comes from the fact that we're trying to pack 3D data into 2D and then be able to unpack it and have as good of a 3D representation as possible after all of that is said and done. Actually, not only 3D, we want to work with temporal information as well, so it's time dependent as well. Yeah. Maybe if I would give up on min and max height, maybe we can do something else here. It would be very cool to experiment with a 3D texture, but I don't want to do it. I don't think it would be manageable in the end. Or yeah, it would be too computation heavy in the end. But maybe we shouldn't even care about min and max height, honestly. A 3D texture for our activity. So instead of trying to pack 3D data into a 2D texture, we pack 3D data into a 3D texture. So we just add a y coordinate. Yeah, the entire problem as I see it is how the hell do we handle just stuff like this, for instance. So we have our data point here. First, let's say the character runs through, we have a min height, max height, we pack it into the data texture, but then this one comes around, we have a new min and max height. If we just override it, we won't be able to represent the snow here as being walked. I don't know. I don't have a clear vision of what we need and how to achieve it here. It sucks. That's pretty much why I'm leaning more and more towards just settle on something, make it work, like implement it from start to finish, and then we start working with it in our shaders just to see how it looks eventually. Like if we skip min and max height and just go with velocity and timestamp, velocity strength and timestamp, and just play around with that. We just assume that everything's saved. Everything's saved in the data affects everything. I don't know. Or Like, I'm even having a hard time thinking about, okay, what if we have as many bytes as we want to represent or to compress the data of whatever is occupying a data point. We want to pack it. We can, let's see, we can we want to package it down to a 2D texture-ish, where each pixel of the texture can have how many, how big a values as possible, or how many values as possible. And we want to pack it down to this 2D texture in such a way that we can then unpack it and reconstruct as good of a representation as possible of the 3D space. Like, we want to take what we see here on screen, repackage it down to a 2D texture, and then we want to package it up again and reconstruct it to be as similar as possible to this. And we want to do it with time in mind as well. We want temporal information. Feels a little bit crazy. So right now we would package min and max height, which means that we would probably get, it's pretty cool if we have a, can I take an image here? Do we have? Like, if we would try and recreate it, it's hard to look at this, but if we would try and recreate this one, it would probably look something like, let's go with 20. Like, if we would try and print this one in 3D space again with the current packaging of data, it would probably look something like this, and that's probably good enough. Like, if we could manage to pack, fuck, did I screw up? No, I don't think so. If we would manage to pack min height and max height, and So it's pretty much we pack blocks of data like this with a velocity and a velocity and velocity direction and velocity strength. But also, and with the current setup, if we would have an additional object up here, I don't know, then this data would be like this. And yeah, we would get some weird result here, but I think it would be okay. Cynic love lurking on Twitch while having a meeting or two. Yeah, sounds good. Okay, two problems with this. We start getting bigger problems when we want to decide when and how things should overwrite this. But let's just say that every time we have something on a data point, we write min height, max height, velocity direction, velocity strength, and timestamp to that data point for whatever is located on it right now. If we do that, then we have a problem with the implementation currently, because what we do here, if we want to write min height here, we use color mask R, which means that we only write to the red channel, and we do blend operation minimum, which means that we only write to the output if the value we're trying to write is less than this value. This won't work. Like if we try to overwrite this one with a smaller value, it won't work. Like we won't do it because of blend operation here. So I don't really know how to go about implementing this. So as I said previously, it's pretty much we want to do check the timestamp. If the timestamp is smaller or a previous timestamp, then we overwrite everything. If it's the same timestamp, then we want to do this shit. But I don't know how we would properly do that. If we rendered this to a 3D texture instead, we would get a lot for free, I think. But how would that work? And now I might just be going insane. Unity shader that renders to 3D render texture. Probably a little bit overkill. Yeah, I'm gonna have to think about this a lot. I'm gonna try to so when I stream tomorrow, I'm really gonna try to have a plan figured out for what to do next here. If I don't have it, hopefully I have something else we can do. I just have to find a point where like I just need to figure out the golden point between the data we need and how to store it, and yeah, I don't know. But yeah, I'm gonna have to figure out a plan and get back, because I gotta run now. Yeah, let's just put it at that. So thank you so much for watching, everybody. I appreciate it. Hopefully we will see some more progress tomorrow. Have a great one.